Welcome to calculus. Fractions will pop up when you least expect it. On this episode, Stevenson will demonstrate
Remember when we're using definite integrals, we're actually finding area under our rate function, right? So remember we used rams to approximate, we used trapezoidal sums to approximate using trapezoids, we might use geometry formulas, we could also use antiderivatives. We need to remember that the definite integral can be interpreted as the net area between the graph of a function and the x-axis. What that means is that using the antiderivatives now, it is possible we can use still the net area. That means, though, is that any area below the x-axis is counted as negative. So there's a difference between total area and net area. So the net area is when any areas below the x-axis get counted as negative. However, if you just want the total of something, then that means all areas are treated as positive values. So there is a difference between net area and total area. In general, if you're asked to find the area of a graph, typically it means the total area. So that would imply all of your areas are positive regardless of where they are. So that's why if you look at step 3 in the process of how to find total area analytically, you put absolute values in your answers to ensure your outputs are positives. Let's practice using our definite integrals and specifically our fundamental theorem to calculate the area of a region. So we want to find the area of the region between this curve on this interval from 0 to 3, it's a closed interval, between this curve and the x-axis on this interval. So the first thing we want to do is generate a picture of this. Now this is a concave down quadratic, it's a parabola, concave down. It's been translated up 4 units. We can kind of generate a sketch. The problem's asking for the area. So remember, we're going to interpret that as the total area. Now notice on my picture here, I have a section that is above the x-axis and a section that's below the x-axis. So in order to compute this area, I'm actually going to do 2 separate definite integrals. One for the interval from 0 to 2 and one from the interval from 2 to 3. The antiderivative will be the same for both. However, when I go to compute my area on the interval from 2 to 3, I know it's going to be negative. So I'm going to use absolute values to turn it positive, and then thus that'll give me the total area of this problem. So the integral of the total area, okay, so the integral from the 0 to 3 in the whole interval is really the integral from 0 to 2 plus the integral from 2 to 3. So I'm going to start with the integral 0 to 2 first. So what I did is I have my integral from 0 to 2. This is my antiderivative. I did reverse power rule. And then I'm evaluating my antiderivative at the upper bound minus the antiderivative at the lower bound. Now the nice thing is this is just 0. So really, I just have to simplify this quantity, and then I will have my first area. Now I'm going to do my second interval. Now this integral, So this integral is on the interval from 2 to 3. Now remember, I know my area is going to be negative. So whatever I get, I need to make sure it stays positive because I'm trying to find total area. Now in this case here, notice I'm integrating the same function. So I already know my antiderivative. I already did the work up here. So all I have to do is rewrite the same antiderivative, but with the new bounds. Now, we knew we were going to get this negative area, right? So to find my total area, what I'm going to do is I'm going to take the sum of the two areas here, but I want to make sure I'm dealing with the positive areas. Now I want to show you something with your calculator here. If you type this into the calculator, watch what happens. Now do you notice it got 3? Why do you think that is? It's not the answer we got, is it? Did you figure out that if you don't do the absolute values here, you would do 16/3, take away 7/3, which is 9/3, which is really 3. So your calculator does the net area. So you might be thinking, well, what do we do? How do we fix this, right? You need to type in the integrals individually. However, put this integral as an absolute value. Now do you see we have our answer?